here I want to show that secant theta over sine theta is actually equal to tan theta plus cotangent theta. It's a problem involving identities where I have to substitute in certain expressions that can replace the functions that are there. So I might think of some identities that I have. So here's some important identities that could help with this. Tangent theta can be rewritten as sine theta over cos theta. Secant theta is 1 over cos theta. Cosecant theta is 1 over sine theta. And cotangent of theta would be 1 over tan theta, which could also be written as cosine theta over sine theta. That just comes from flipping the fraction of sine over cosine. So now I would go through and look at some of the expressions that could be replaced. Secant theta, I'm going to replace that with 1 over cos theta. Tan theta, I'll replace with sine over cos. And cotangent theta, I could also replace that with cosine over sine. So let's start with that. I'm going to replace secant theta with 1 over cos theta, but we still have to keep the sine theta in the denominator as well. For tan theta, I'm going to write it as sine over cosine. And then cotangent theta could be written as cosine over sine. So this is better now that I have everything in terms of sine and cosine. It's just simpler. And now I could look for what could I do next to simplify the expression, perhaps getting these two fractions into one fraction. So one thing that comes to mind is getting a common denominator. What I'll do is I'll multiply the sine theta over cos theta by a fraction of my choice. I'll also do the same thing to this term. I just want to make the denominators match. Right now they don't match, but they would match if I was to introduce a sine theta here and a cos theta there. In fact, the denominators on both the left and right would now match. I have to multiply by something over itself, though, in order to change the fraction. And now we get left with this. Okay, so whenever we have a common denominator like this, where every term has that same denominator, we can actually remove those denominators. And we get it down to this. And this actually is a known identity. Sine squared theta plus cosine squared theta is equal to 1. So we have 1 equals 1. So we can also use a graphing program to analyze this kind of situation. For example, if I start with the original and let that be a function here, so if I type in the left side of the equation into Desmos, I can see a graph of what the left side would look like. And then I can type in the right side as well. And what we see in the graphing program is that these are identical graphs, meaning that in all likelihood, this is true. We could do the same thing for this identity here. Y equals 1 is just a horizontal line. And we see that sine squared x plus cosine squared x is also equal to 1.